Okay. So far we practice with this electromotor, with induction motor, and this induction motor driving the generator. If I have a chance, I could show you. If I connect this one to light, I could get some voltage. But that's a generator or synchronous motor. The synchronous motor, if you drive it, it becomes generator. Now we're going to use this one with a closed loop with its own decoder. To use, you can apply all of these parameters manually to, or you can get this information through its own library. Mostly PLC, VFD, they have their own library. You can use that library. To use that library, you have to switch the motor. Now this is synchronous motor. Then you are going to control that. This program has some features. If you need to use that library, you have to set the mode. Set the mode and region. So far, we practice with open library, open loop. If you want to use its library, set it to RFC S, rotor flux control. You remember this one in the lecture for synchronous motor. Okay, we are choosing this one to use the library. Okay. Now everything's here. Now we are going to use the library now. The library, to use the library, I have to go to setup. If you don't want to use library, you have to put everything manually, which is pain and maybe it's not precise. This one, synchronous motor, has more parameter than induction motor. But then it's good to practice as well. Go to motor setup. In the motor setup, these are the parameters you have, but because you don't know all of these parameters, you can choose a motor. Look at your instruction. Find the motor. What is the model of motor you have? The model already here. I think I already wrote down. You can search the instruction and say, help me to find the right motor. The motor is, you have this option, servo. These are different forms of motor that we have. If it's not here, we go to next one. Let's see if you have that one here. Can you see what is the motor? What is the model of the motor? This information is written on the nameplate. The model information I can share with you. Let me stop sharing this one. Share. Where is it? There you go. This is the model 067 ED B300 BACRA. Okay. So write down this number in corner. And otherwise, you have to apply all of this information manually and include the encoder. Encoder, you have to apply that one as well. Let me go back to that M-Connect. Share that one. The connect. Okay, 067. Go with model. Okay, 05. Let's go down to 067. E67E, okay, and then D 67E2, 67E3, oh. ED B 670 67EDB, is that right? 67EDB 300. Is that the right one? At the end, 300. Is that the right one?
It looks right to me.
Looks right. Yeah. So I choose this one. All of parameters are automatically loaded, which is good. Okay. So the motor parameters you can write down. You can write down these motor parameters. You already have it. You can get a screenshot, have it. The next one that you have to apply, if you want to go through that feedback here, speed reference, you can have it everything in motor feedback setup. Because you already select this number, write down this information because you need this one in your lab instruction, first of all, and you need this information when you are going to control that asynchronous motor. That asynchronous motor, you need to apply the feedback is the same as this one. So when you upload this motor, because the encoder is attached to the same motor, the feedback information is already uploaded. So I write down this information because I need it for my next experiment. Okay. Encoder. Okay. Hopefully you write it down because you need it for next experiment. Okay, now we go to do that menu again. The motor parameter, motor setup, okay, is here. Because this is part of the library, you have to send this from the information drive manually. This information is not in drive until you manually send it to drive. It's not something, you're just pulling up something from the drive, from the library. Now you select your motor, send it to drive. Okay. When you send that drive, the parameters here are sent to. We can double check everything here. It seems everything's fine. Am I right? It seems everything's fine. A speed reference. These are seems okay now. A1, A2 sounds good. Okay, let's try it. So we need to reset it because we just inhibit that the drug is not ready. Let's go with lower voltage initially. And then start. Then it didn't work. Maybe let's see why it stopped. Go that one. Let it stop. What's on? Maybe the feedback. What you need to consider is, you remember if I change the order of A1, A2, A1, A2, A3, the motor might go other direction. What does it mean? That is if the motor feedback setup, there is a chance the feedback is reverse. Okay. I just double check that one to see why it didn't work. and start again. Okay, didn't work. Maybe. Parameter. Oh, I think the parameter now is time for parameter for PID. Parameter, I move back that feedback reverse, go to PID parameters because now is feedback. It is a feedback, now go to a loop control. A loop control is supposed to have some PID parameters set. We have to go for tuning to get some parameters. For PID controller, practically you have two options: manually tune it, or go with this one. This program has option with auto tuning. Get some tuning parameters. Please ensure they have nothing kind of attached to. Okay. Stationary, this one. Next. The drive is trip. Cancel that trip. Okay. Next. To start the auto tune, please enable the drive by activating the drive enable to save torque up. Means this one. Now you start drive is enabled. It start tuning. Getting some parameters for PID. When it says stationary, that means okay, auto tune failed because the drive tripped during the auto tune. Oh, back to return, see why straight drive hardware enable safe torque is active. With the right select. Describing auto tune. Let's look at the log. Why this one is tripped? Encoder. Okay. It has some issue with the encoder. Let's go to feedback again and change this parameter. Set drive and come back here for tuning one more time. Reset it. Okay, next. Disable the drive. I have to disable it. Now go with next. To start, let's enable it. Okay, the feedback works fine. Finished. Disabled. Okay. Now everything's fine. Next. These are some parameters, changing parameters. Okay, write down this information, everybody. Parameters change. Save parameters. Okay, hopefully you have this information. Save parameters drive. So it got some numbers for me. Now this parameter is saved drive. Okay. So these are the parameters. You see the parameters is 517, 560. stator resistor, current at maximum, the number changes in ohm in percentage. If I go back to auto tune, I did this one, okay, and I can now change the rotation. So the stationary tuning and rotational tuning now. Okay. Next to run. To start, this is supposed to be enabled level. Start tuning. For practically for forward, reverse, you may have different tuning. It just changes the drive to see, okay, it trip again. Trip, waiting disable. What happened? Failed because drive trip. I go back here. Change this on one more time. Oh. Okay. So go to auto tune. Cancel everything. Start again. Rotationary. Let's try again. Okay. Remove that one. Start. Practically want to make sure that everything is not done just based on software. Is start rotating the motor very slowly to get some parameters. Didn't get it. Trip. Okay, let's look at the log. We'll see what's wrong. For one, reverse, forward. What is not tuning? Everything's fine. It is wrong. So the connect to auto feedback device connected to, because in this case need some device sensor position feedback. Is right. Feedback reverse off. So feedback device connected to. Share interface one on the and one more time. Hopefully this can help me. One more time to check the auto tune. Let's go. Okay. Enabling it. During the auto tune. There's next. Just start tuning. Hopefully this, otherwise that load is supposed to be detached from the motor, which is time consuming. Because if it said initially to detach every load from the motor to get the parameters for the auto tuning. It didn't like it. Oh. Yes, something stupid. Anybody can help me? I did something stupid. Can you say what's wrong? My mistake was here. I forgot to move this one from motor to the generator. That was my mistake. Let's turn on. Move this one from motor to second one. I pick everything for this side. And then forgot to move the cable. Okay. Now, if I apply this one, hopefully it has some number. Okay. Now it's good. Let's try again. Hopefully, you got what I'm saying. I forgot to switch the motors. Let's go with the stationary one more time, because the stationary parameters already set for that motor. So enable it, disable it again. Start tuning the stationary and then go with the rotary. Okay, finished. Perfect. Remove that one here. Now I can have these parameters. Go to next. Write down these parameters. Write down these parameters because you need these parameters 325, 413, 414. The current control KP gain, KI gain, and so these parameters are based on the tuning. Okay, save parameter in drive. Okay, parameter saved in drive. Now go back and go with the rotating parameters. Next. To start, I have to press this one to start that tuning. It start rotating. I don't know if you can see it or not. It starts rotating a bit to get some parameters for the auto tuning. Failed. Why this one is failed? Let's see what they made a mess here. Okay, that was my mistake. Go with auto tuning one more time. Okay, start over. Disable try. Enable it again. It'll start tuning down. So you can see it's just a stop. It is supposed to move a bit. Okay, auto-tune R is successfully done. So I have to say that to remove that enable. Okay, now continue with this one. Next, these parameters you need it. Make sure to write down these parameters for me. Okay, save this parameter in Drive. So we have two PID. One for stationary, that means no load. The other one was for rotating. So we made auto tune. Now it's good to start. We go back here. And then let's go forward. Let's start rotating now. Let's start rotating now. This is your actual speed. It's 9 speed. I don't want to this one stop right there. I can go to reverse now. This is the reverse now. It goes to reverse now. So next 17, I'll change it to smaller enough. This is the actual RPM. This is the actual RPM now. Previously, you didn't have this number, you just have some frequency, some hertz. Now you have this number. So what we did so far? We changed the motor from induction motor to servo motor, which is a synchronous motor. A synchronous motor with encoder. We apply the parameters for the motor. We pull up this parameter from the library. We have the library. We know the information for this encoder. Okay. So now this motor can go up to 3000 RPM. This motor drives the induction motor. The induction motor now is practically the load for this motor. What we did, we tuned this motor, we auto-tuned this motor for two PID, stationary and rotating. You have the parameters for PID for me now. The next would be using this motor, the induction motor, with this feedback. Initially, we had this induction motor as open loop. Now we are going to use this motor with the feedback from here. You already know this information. is feedback information. Next is using this motor, switching this motor, asynchronous motor, and practice this will be the low, and this is your feedback. Just have a break and then continue this one. Okay, anybody questions so far? Did you find it useful so far or not? So give me a feedback so far. Anybody want to say something? Okay. Let us stop sharing.
Just checking. You're tuning while in open loop, correct?
The tuning, say it again.
When you're tuning, that's done in open loop, correct?
The open loop didn't have a tuning because there was no PID for open loop. This is for closed loop, for synchronous motor. If you look at here, motor, set motor and region, you see we are in RFCS. You have this one in the node. Router flux control for synchronous motor, which is closed loop. When we have that encoder, the encoder is used for closed loop. Okay. Next, we are going to use with RFCA, which is router flux control for asynchronous motor. Now, still we are in RFCS for synchronous motor. And my mistake, I forgot to move this one from this motor to that motor. Now I need to move it back for the next experiment. Okay. So I move. Anybody question? Make sure to have these parameters. And then we need this one for next one, encoder, especially the encoder one. So I switch that one to RFCA and apply my motor. And in front of you, I'm going to move my connector. From that one to operational motor. But in this case, you are using the feedback. Okay, let's have 10 minutes break and then continue after that.